Hey everyone, in this video I'll be talking about my most favorite topic ever, visualizing program execution. And I'll be doing this in Java because I've been tutoring a bunch of APCS students, and APCS is in Java. But what none of my students have been able to do is draw visuals for their Java programs. And this is such a critical skill for beginners because how can you really understand a piece of code if you don't have a mental model of what's going on? And so that's what I'll be teaching you today. These visuals are based on Philip Guo's amazing tool Python Tutor. It was originally developed for the Python language, but a lot of the concepts translate well. You can play with it yourself at pythontutor.com. So thanks to Philip. Let's move on. Before we begin, you have to know that there are two categories of data types. The first is primitives. Primitives are copied everywhere because they're so simple. They're just numbers like ints and booleans. Object references are also primitive values because they're essentially just numbers that point you to where the object resides in the heap. The second category is objects. Objects are shared because they can be more complex, and it'll be very costly to copy them over and over again in your program. So these include strings, arrays, and array lists. So as a result of these two categories, computer memory is also organized into two areas. The left-hand side is a stack where primitives and object references live, and the right is a heap where all objects live. And you can see in this example that the car object is shared between the two variables, parent's car and my car. Let's begin by working on a simple assignment statement. Every method call, including main, which starts your program, will have its own stack frame. A frame keeps track of variables and their values. And so for this example, we have two variables for the main frame of primitive demo. We have args and we have x. Generally, we can just ignore args if we're not going to use it. So let's just focus on this int x equals 2. So 2 is a primitive value, and x is a variable that holds data of type int. And so you'd write int x has the value 2. Now let's look at a more complicated example. So when you see string z without a declaration, you can write string z. You know z will hold data of type string, but if there's not a string that z holds right now, then in Java you have the null value for variables that don't reference any object. Meanwhile, you have string y equals world. So how does this look different? You still have string y, z and y hold the same type of data, but now you have a reference to the object world, which you can note as a string, like that. Okay, so then what happens when you say z is equal to y? Well, for assignment statements, you look at the right-hand side first, see what that is. Okay, y is this arrow, and then you're replacing the existing value of z with this new value. So z is no longer null. Z also points to the same string world. All right, now we have y equals hello. Hello is a new string that you create. And then we're changing the value of y into this new string. And so finally, when you say system.out.println y plus space plus z, y now points to hello, z now points to world. And you end up printing out hello world. So this is a good taste of seeing how primitive values are treated differently from object values. Now let's cover how to work with method calls. So with this demo, we start with the main frame as usual. And in public static void main, we have int x equals 10. So let's write that down. 10 is a primitive value, so it lives in the frame. And then we have a few method calls here, system.out.println and add5. What you want to do is you want to work inside out. So inside system.out.println, we need to figure out what this is. And inside add5, we need to figure out what this argument will be. And so x, if you look it up in the main frame, is 10 plus 1 will be 11. So now we've evaluated what we'll pass into add5. So that's step 1. Step 2 is to create a frame for add5. And then we see that add5 has one parameter x. This int x will be the value that we evaluated. So now we're ready to enter the body of add5. And immediately we see another method call add4. So step 1 is to evaluate all arguments into add4. This x here is now 11 because we're in the add5 frame. And so now we create a new frame for add4. The parameter of add4 is x, which we can fill in with our evaluated value 11. Now we execute this return statement. So return takes us immediately out of the function, and we can denote a return value in this frame as 15. And so we're done with add4. We can cross out this frame, and essentially this method call here can be replaced with 15. So now we have 15 plus 1 is 16. We're returning 16 for add5. So return value is 16, and we're done with that now. Okay, so we understand that this add5 of x plus 1 is eventually 16 for our program. We don't draw out system.out.println because it's a built-in function. There's no need to draw something out if it's not our code. And so we're done with the visualization, and our output is 16. Now let's work with objects. So we have main here, and the first statement of main is a constructor call. Car Camry equals to new car Toyota Camry. Now we do the right-hand side of the assignment first. When we see the keyword new with a car, we're going to create an empty car instance. And so this will be a car with nothing in it. And we fill in the instance fields here. So string make has nothing. String model also has nothing. And int year sold is also nothing. Now the difference between string and int is for int the default is 0. For strings the default is null. So we can write null there. All right, so we create a new car with nothing in it, and what the constructor does is it initializes this object. So we're in the constructor now. We have the parameters make and model, but in Java you actually have this built-in variable, and this refers to that object there. So additionally, we have string make and string model for the constructor, which comes from what you pass in. So notice how this string make and string model are distinct from the make and model that belong to the object. So we're just creating the frame for the constructor. This is similar to a method call. We're passing in Toyota and Camry. Okay, so now we've prepared the parameters for the constructor. Let's run through this code. So when you see this dot make equals make, right? First, the right-hand side make refers to this string. Now you're setting this. The dot notation means you follow the arrow. So this dot make, this value in the object here is no longer null. It points to Toyota. So that's what this assignment does. This dot model equals model is similar. So this dot model is now pointing to Camry. And then there's nothing left to do in the constructor frame, so this goes away. We're done with that. And this resulting new car is assigned to a car variable in the main frame. So car Camry is now pointing to this object. And so after that, we have Camry.sell2020. So this is a bound method. What happens is we're gonna, so unlike a static method, right? Bound methods will have this assigned, right? Because we called sell on this specific Camry object. So this points to the object on which you were calling the method. And then what parameters do we have to fill in? We have to fill in year. So int year is 2020. So now we're able to go through this body now. So this dot year sold equals year. So this dot year sold previously was 0. We're going to replace that with 2020. And then when we print out sold, make, model, and year, if make is not present in the current frame, then in Java by default you use this. So make will refer to Toyota, model will refer to Camry, and then year is the same year as the parameter here, which is 2020. So we'll end up saying sold Toyota Camry in 2020. Now this behavior of looking up make using this dot make if it doesn't exist in the frame is Java specific. If you did this in Python, for instance, it's not going to work. You're going to have an undefined variable. But at least Java will check to see whether it's in the object first. Let's try to understand static a little more. So what static means specifically is defined before the program is run. So during program execution, you're going to create lots and lots of objects. But you may need to call some methods or define some data before you start creating all those objects, especially the main method. And so that's why the main method is always static, right? You need to know what to call before you start creating any objects. And so in static methods, you can only reference static definitions because you haven't created any objects yet, right? But once you do, in this case, static demo my demo equals to new static demo 6, you can now work with X or print my num because you have an object to do those with. So where does static data reside? When I said computer memory is organized in 2 sections, it's actually a simplification. Your code and your static data also lives in memory. So let's draw a section for that. So static demo has a main method and y equals 5. So now we call this main as we have done before. When we say system.out.println, well, it's not in the main frame, but this main frame is part of the static demo class. And so we know that y is actually going to be 5. Then the next line we have static demo my demo equals to new static demo 6. We create a new static demo object. So y is not a part of this because it's part of the class and we already know that it exists, right? But this x is going to be new, and by default this will be 0. All right, so we start the constructor, which is static demo, and this parameter x will be 6 because that's what we pass in. And so we say this dot x, oh, I forgot, this points to that new object. So this dot x is equal to x plus 1, so that will be 7. We're done with the constructor, and this static demo variable, my demo, points to this object. And so we then have my demo.printMyNum. We create a new frame called printMyNum. We don't pass in anything to it. So where do we get the values from? Well, when you call a bound method, the method has a reference to the object. So then there's no x in the frame printMyNum, but this .x exists. All right, so this will be 7. Now what about y? Well, this y does not exist, but y belongs to the class. So actually, we do know what y will be as well. Y will be 5, and so we print out 7 plus 5, which is 12. And we don't return anything here. System.out.println doesn't return anything. And so we're done. So now let's go over arrays and loops, and what you'll find is they're not that different from what we've been doing before. So we start with main as usual, and now we have an assignment statement. array 2D is equal to this expression. Let's take a look at this expression. The outer braces tell us that it's an array with 2 elements. First one is an array of 1, 2, 3. The second is an array of 4, 5, 6. So we have a 2-element array where the first element is 1, 2, 3, and the second element is 4, 5, 6. All right, and so now we assign this array by reference to int array 2D. So arrays are objects. We don't copy them around. We reference them. All right, so now we're in the loop here. We have for int I equals 0. We put int I equals 0 here in the main frame, even though it can be accessed only in the loop. So I starts at 0. We're comparing I against 2d.length. 2d.length is 2. So we're good to proceed. Then we have for int j equals I in this case is 0, so j will also be 0. Is j less than the first element of 2d's length, which is 3? Yes. So we're good to proceed there as well. Now we have system.out.println 2d of ij. What I like to do is I like to keep a separate list of output, and 2d of 0, 0 is 1. So once we're done with that, j increments. We're in the inner loop. J is now 1. Now we compare j with 2d 0.length, which we know is 3. We're good to proceed again. And so now we print 2d of 0, 1, which is 2. J increments. J is less than 3. We keep going. We now print 0, 2. So we print out the value 3. J is now 3. 3 is equal to the length of this first array, and so we're done with this inner for loop, right? So I increments now. And so is I less than 2d.length, which is 2? Yes. So j becomes I. In this case, I is 1. So j becomes 1. And so is 1 less than the first array's length, which is 3? Yes. So we go inside, and now we print out 1, 1, which is the value 5. Okay, j increments. Is j less than the first array's length, which is 3? Yeah. So now we print 1, 2. So 1, 2 is the number 6. Okay, j is now 3. J is now equal to the length of the first array. We don't do this inner loop anymore. I increments. Now I is equal to the length of 2d, and so we are done with the outer for loop, and that's it. This is the output for this example. All right, and for our final example of the day, we'll be talking about inheritance. How do we visualize subclasses? And so let's just start with main, because we know how to do that at least. Okay, so we have an assignment statement now. Square fave shape is new shape fave shape is new square blue. Now shape is the higher level class, square is a more specific class, but what we're doing is we're creating a new square instance. So we're creating a square object, and square extends shape, so square will also have the string color field. So we'll write that down. Okay, so right now it's null, right? Because we haven't initialized it yet. All right, so we call the constructor of square. So square's constructor has a color parameter, but first let's make sure we got this here. Okay, and now color is the string value blue, because that's what we passed in, blue, to the constructor square. Okay, so what we do is we call super of color. Super is a keyword in Java that'll automatically help us locate that. We need to call the constructor of shape, where the string color is this blue, and this is this object here, right? So now we say this dot color equals color. So this dot color goes from null to this value blue. we're done here. All right. And so this square constructor is also done. But what's interesting is in main, you now have a variable that holds shapes. So shape fav shape points to this square. Okay. But what's neat about using shape here is you can put in any shape, not just square, but soon we'll have evil circle. So I'm not going to go through this constructor dance for evil circle, except to say that evil circle will have a color field, that's a string, which will be, so when you call the constructor for evil circle, what we pass into super is yellow minus the last letter. So this will just end up looking like YELLO. And then we then assign fav shape from the square to the evil circle. And so when we print out fav shape's color, evil circle still has a color because it extends shape. It has that field. And so we'll print out the right thing here. But yeah, just notice that the variable's type doesn't always need to be the type of the object that it contains, because as long as the object is a subclass, then this assignment is fine. In fact, we won't go into this example, but if evil circle overrides a method from shape, then if you say fav shape dot that method, we're going to use evil circle's method because the shape we're working with is itself an evil circle, not just any shape. Well, we covered a lot today. Hopefully you find it useful to have a mental model of code as you read and write your own programs.